Hello everyone, so welcome again to my YouTube channel, and today we're going to start our topic, that is OSPF states. So if I talk about the OSPF states, so there are 7 states in OSPF in which the neighbor relationship will be created and the synchronization will be done on the last state of OSPF. Okay, well, let's talk about the first state. The first state is the down state. In down state, there is no data flow, or you can say the OSPF process is not running either. Okay, but why do we need these 7 states? What is the output of these 7 states? The output is that there are 3 tables in OSPF. What are these tables? The neighbor table, the link state database table, and the routing table. The neighbor table has the information of all the directly connected neighbor of OSPF. The router that are running with the OSPF, those information will be collected by what? The neighbor table. If I talk about the link state database table, it contains the entire network information of the topology, and it is used to calculate the best path. That best path will be available in the routing table also. In the routing table, you will find all the best path, the list of best route, as well as the directly connected neighbor. Okay, so all the 3 tables will also be created in these 7 steps, and we will also discuss about these. That how does the tables will be created in this scenario. Okay, let's start with the down state. In down state, there is no data flow will be there. That is means no hello packet will be forwarded from any router. Nothing will be forwarded, or you can say the routers are disconnected or is not running with the OSPF process. This is the initiate state of the OSPF in which no data will be received. Okay, let's talk about the next state. The next state is what? The init state. So, dear all, if I talk about the init state, a hello packet will be generated whenever we will advertise this network on the routers. The router will start forwarding what? A hello packet. But the hello packet will only contain its basic information like source IP address and the basic information, but it will not contain the router ID. The packet does not contain the router's on router ID in the neighbor list. But let me tell you clearly, the neighbor table will be created in this step. In between the init state and the two-way state, the neighbor table will be created. Now you will ask me, sir, how it will be done practically. So this is my network R1 and R2. In between these two, we will set up the neighbor relationship. So for that, first of all, we will provide the IP address. Okay. So let's go to R1, configuring terminal interface F0 slash 0, 0 slash 0, no shutdown. Okay. IP address is 192.1, sorry, 200.0.0.1. Dear all, this is 200.0.0.1 basically. Okay. So let's provide this IP address, and the subnet mask will be 255.255.255.0. Okay, let's capture the packet on Wireshark. Just right clicking, click here, and the Wireshark will be started. Here you can see there is no packet forwarding for the OSPF because we didn't have configured the OSPF. Okay, let's first of all provide the IP address, configuring terminal interface of 0 slash 0, no shutdown, and IP address is 200.0.0.2. and 255.255.255.0. So we have just provided the IP address only. So there is no OSPF packet forwarding in between R1 and R2 because there is nothing like OSPF. Okay, let's configure the OSPF there, then we will find the hello packet will start forwarding in between these two. For that, first of all, advertise this network on this router R1. Then R1 will start forwarding a hello packet to this site. Okay, let's do the same. How we can do that? Just configuring the OSPF router OSPF1 network 200.0.0.0. Okay, 0.0.0.255 area 0. Dear all, in our last class, I have covered the wildcard mask. This is the wildcard mask for this, for the reference of this. Please go through our last video. Whenever I will advertise this network, and let's go to Wireshark, you can see a hello packet will start forwarding. This is our hello packet that will be forwarded in our in every 10 second in between the neighbor routers. So in init state, the hello packet will start forwarded in every 10 seconds. So you can say that in every 10-second of interval, a new hello packet will be automatically generated. Okay, so that is means routers will start forwarding the hello packet to the neighbors in init state and will also create the neighbor table in between init state and the two-way state. So this is what we have just seen. The hello packet will be forwarded. The destination will be a multicast address 224.4.0.0.5. That is mean this packet is only generated for to find the neighbors, the OSPF neighbors. So in every 10-second of interval, this packet will be forwarded. Okay. Next state is two-way state. In two-way state, what will be done? The neighbor table will be created. After that, the routers will select or elect the designated router DR or BDR. What in this state indicates that the bidirectional communication is established between the two routers. After creating the neighbor table, they will establish the two-way communication channel. The router have seen each other's router ID. So in this state, the router ID will also be exchanged and the DR and BDR election will be done on this state. Okay. So whenever we will configure, let's configure the OSPF on other side also. Router OSPF1 network 200.0.0.0.0.0.255 area 0. Now the data will be forwarded and neighbor table will be created. If you want to check the neighbor table, put a command where on this, I'm talking about this one. Okay. So to check the neighbor table, what we have to do? Put a command show IP OSPF neighbor. So you can see that this is our neighbor table in which we have the neighbor information because there is only one neighbor 200.0.0.2. This information is available here. Okay. So let's get back to our slides. In two-way state, this will be done. Our next state is what? The next state is Exstart state. In this state, the routers will establish a master slave relationship. The router that will have higher router ID will become the master router. If I compare these two routers R1 and R2, this router has higher router ID. That is why R2 will become the master router. And the master router will forward the database description first. But in our exchange state, it will be forwarded. So router will establish the master slave relationship and master will forward the data first or DBD message first. Okay. Here in the exchange state, the router will forward the DBD message. Now, what is the meaning of this database description packet? Let me tell you clearly, the database description is the summary of entire database. The routers will not exchange the entire database, but will only forward the database description, a short description of the database. If the description will be matched, then that is okay. If the description will not match, then the router will exchange the request message will be forwarded, and then the entire database will be forwarded in form of what? LSU, but that will be done in our next state, that is called loading state. Well, if I talk about the exchange state, only DBD database description packet will be forwarded. Let's do this practically. If I go to this router, so here you can see that the router has forwarded the database description packets here. What? Database description packet was forwarded in between these two router, but as these two are new routers, so the database table, the DBD message will not match each other's database. So DBD message forwarded in between two will not be matched with the database. So it will request the entire database in our next state. That is called what? Loading state. In loading state, first of all, router will forward a request message. I need entire database. My database is not matching with your database. In response of that, the router will forward an update packet. Then whenever the database update packet, in this update packet, the database will be there. The entire database will be forwarded. When the entire database will be received, it will forward an acknowledgement. Yes, I have received the data. Then the database table will be created. We call that LSDB table. The database will be forwarded. The entire database will be forwarded, and they will create the database table. Okay. Let me show you these packets. So these are the packet that will be received. So this is the request message. First of all, the routers will forward a request message. In response of that, the routers will forward what? Update packets. So you can see that updates are available here. In response of that, the acknowledgement will be forwarded. In live, you can see that these are available here. First of all, the request message was forwarded, and in response of that, the update message will be forwarded, in which the the entire information of the database will be there. Okay, and in the end, the acknowledgement packet will be forwarded. That what I have show you in this loading state. So that's all will be done in loading state, and in our last state, that is what? Full state. The routing table will be created on the behalf of previous data flow link state advertisements result. The routing table will be created in, and in this table the information of directly connected neighbor as well as the best route information will be available. Okay, so dear all, this was the 7-step process of OSPF. If you have any confusion with this OSPF 7 states, you can ask me in the comments. I will create a video over that. Dear all, don't forget to subscribe the channel and have a nice day. I hope you like the session.